So picking up where we left off there in part 1 of this lesson, this section is exploring the value of A. We were exploring the value of B just a moment ago and how it affected the exponential growth or decay. Notice if we're using different values of A, let's try 3 for example as a base. So A here is actually 1. Here A is the multiplier, 2, then 5, and then a half, or 0.5. So we have the graphs over here. We have the original y equals 3x, so A is 1. What happens if we change A to a value of 2? We see it's closer to the y-axis. And if you consider the next one, if A of the multiplier is 5, again it's closer still. Now remember transformations again, when we have values like this, it's actually a vertical stretch by a factor of 2, by a factor of 5, by a factor of 0.5 from the original here. So if it's a vertical stretch, if we are at a height of say 1, 2, 3 over here, then in doubling, going from y equals 3 to the x to y equals 2 times 3 to the x, this should go up to a height of 6, so 4, 5, 6. And we see that we do have a point vertically above this point, so that's an indicator of what's happening. It's a vertical stretch by a factor of 2. And here by a factor of 5, so we could take maybe a height of, I don't know what the scale is, 1, 2, 3, 4, 5, 6, 7, 8. So we start at 1, which is right here. We should go up to 5, 2, 3, 4, 5, and we do when we're using a multiplier of 5. What happens when it's 0.5? Well, if it's this should go down from a height of 3 to about a height of 1.5, and it does. Okay, down here. Okay. Graph the functions using a graphing calculator, so you can get this in your graphing calculator, and then complete the following table for these equations. So let me just scroll down, and values of A were 1, 2, 5, and 0.5. Values of B were consistent at 3, and the y-intercept of the graphs, if you notice, if you rewind this video, you will notice that it was at 1, it was at 2, it was at 5, and it was at 0.5, which makes sense because the y-intercept is when x equals 0. So 3 to the 0 is 1. And in this case, 3 to the 0 is 1, so 1 times 2 is 2. So that gives you y-intercept of 2, and this becomes 1, so 5 ones are 5, and then 0.5 times 1, 0.5 is the y-intercept. What is the effect of the graph on the graph of a change in the value of A? Well, we know it's a vertical stretch about the x-axis. Y-intercept is always the value of A, so we know now A is the y-intercept value. Part D, if f of x equals 3 to the x, write the following in terms of the function f. The function f. Okay, so if it's just y equals 3 to the x, then y equals f of x, because f of x is 3 to the x. This here means we've really doubled the function, so 2 times f of x. This means we've multiplied by 5, so 5 f of x and 0.5 f of x. Which transformations are associated with D part 2, 3, and 4? We know they're vertical stretches by these factors here. What is the effect of the parameter A on the graph? A basically means a vertical stretch about the x-axis by a factor of A being greater than 0. And the last part of the question above was asking where or what is the y-intercept in an equation of this form, and it is at A, whatever A happens to be. So the y-intercept is at A. There is no x-intercept. as we've seen before. There is a horizontal asymptote, and it's the x-axis. The domain for x, all real numbers. X is all real numbers. The range, however, y is greater than 0. As long as a is greater than 0. And if a is negative, if a is less than 0, remember that's the multiplier. If you think of translations, all the y's become negative, it would be a reflection in the x-axis. So if that happens, all the y's would change sign, and our range would change from y greater than 0 to y less than 0. So for a greater than 0, when b, as long as b is greater than 1, the function represents a growth. When b is somewhere between 0 and 1, the function represents a decay function. The value of b affects the steepness of the graph as x increases. So when b is greater than 1, the curve rises sharply as b increases. This is a bit of a review from before. And when b is somewhere between 0 and 1, the curve falls sharply as b decreases. The value of a affects the vertical stretch of the graph. Choose the correct alternative. When a is greater than 1, the stretch is a expansion, and when a is a fraction less than 1, greater than 0, it's a compression. When a is negative, less than 0, there's also a reflection in the x-axis. Example 1. Describe how the graph of the second function compares to the graph of the first. So here's the first, here's the second. How does the second compare to the first? Well, what's happened? Well, we know that we've got a multiplier of 2, so that's a vertical stretch. They're representing it. Replacement terminology, y goes to half y, so it's a vertical stretch by a factor of 2. Vertical stretch. And x goes to x minus 2, so it's shifted to the right, 2 units to the right. Okay. Part B, in going from the first to the second. So we can bring this 4 over to the other side, and we can see that y would now equal negative 2 x over 5 minus 4. So how does one compare to the other? Well, we've also got to look at this x divided by 5. But first of all, we can look at, it's a negative 2, and so that's a reflection of in the x-axis. So if we take our stretches, then our reflections, then our translations. Looking at stretches, it looks like it's a vertical stretch by vertical stretch. Where is this? Yeah, vertical. No, that's wrong. Hold on, just got to think. Oh, sorry, x is right here, and all that's happened is the y's got a negative 1 here. Negative. That's affecting the y, so this is a reflection in the x-axis. I see that now. But the stretch, x is being multiplied by 1 over 5, so that's a horizontal stretch by a factor of 5. And this negative is a reflection in the x-axis, reflection in the x-axis, and then finally this negative 4 is 4 units down. Hopefully that's clear. Moving on to example 2. Explain the following transformations. Why the graph of this is a reflection in the y-axis of a graph y equals 3 to the x. Well, simply this equals 3 to the negative x. So x has become negative x. It's a reflection in the y-axis. y-axis. So here's the example written out here.